All right, welcome back. This is about geometric patterns. That's the focus of today's video. Now, when we're talking about geometric patterns, one has to understand the work that you did in primary school. What work is that? In primary school, you were introduced to 4 different mathematical operations. First operation, addition. Second operation, subtraction. Third operation, multiplication. And the fourth is division. What's the relevance of this? The relevance of this information is that when we say what is the opposite of addition, the opposite of addition is subtraction. And then if you are questioned, what is the opposite of multiplication? The opposite of multiplication is division. Now, where are we focusing amongst these 4? We are focusing here on multiplication and division. Why? Because the geometric pattern, what happens? Check, for example, this number that I wrote here. We've got number 10. From number 10, we go to number 100. From 100, we go to 1,000, right? Now, the previous formula, which I gave you when you're looking for the constant difference, we would say that term 2 minus term 1. We have term 1, we have term 2, and term 3. These are the 3 terms that we've been provided. So if I'm to say term 2 minus term 1, 100 minus 10, the answer that I get is equals to 90. And then I say term 3 minus term 2. Term 3 is 1,000, term 2 is 100. And when I say 1,000 multiplied by 100, I get 900. Now, remember, we called it constant difference. And I said the word constant means something that does not change. But now let's check. We got 90 here. We got 900 there. The answers that we got, they changed. Therefore, they can't satisfy the definition of the word constant, right? Which makes it obvious that we are not dealing with a linear pattern anymore. Hence, it has been named geometric. Then the question is, what is this geometric? Let's rewrite. We are given this 10, 100, and 1,000. When I move from 10 and I go to 100, the numbers become bigger. When I move from 100 and I go to 1,000, it has become bigger. But 10, we've multiplied by 10 to move away from 10 to go to 100. And to move away from 100 to go to 1,000, we multiplied by 10. This is what I'm observing through my eyes and how I understand mathematics. However, in your number patterns, you do not always work with numbers that you can already tell the value just through optical observations. So what do? We have got what is called constant ratio. When we want to know which number did we multiply by. But remember, when you see the word ratio, it means it includes division. So now I say the second term divided by the first term and the third term divided by the second term. Why? We want to check whether we're still getting the same answer. So I say 100 is my term 2. So we say 100 divided by the first term, which is 10. And 100 divided by 10 is equals to what? It's equal to 10. And we go to term 3, which is 1,000. We say 1,000 divided by 100, which is term number 2. Now, remember your primary work. When you've got zeros there and zeros here, they cancel. So basically, we're left with 10 divided by 1, which is equals to 10. And 10 is equal to 10, which means it satisfies the definition of the word constant. We found numbers which are the same. So remember where we started. I started by telling you that here when we are dealing with geometric, we are dealing with what? multiplication and division. So this number pattern which you are having here, when it's going forward, you are multiplying. But in order for you to find out how much did you multiply by, you do the opposite of multiplication, which is division. You now take the number which is forward, you divide it with the number that is backwards. The other number that is forward divided by the number that is backwards. So the first thing we have found it, which is the constant ratio. Now, what is the formula for what? The formula for geometric pattern. The formula obviously is different from linear patterns. We now say Tn is equals to A r to the power n. Now we need to define, right? What does the letter A stand for? The letter A stands for, A means the first term. The first term that you have been provided in the geometric number pattern was 10. So here we have 10. Our A is 10. Then the letter R, letter R represents what? It means constant ratio. And in this instance, we found out that our constant ratio was what? 10. And our first term is also number 10. And then the letter N, what does it represent? It still represents the same thing. It means what? Position of term. Position of term. So let's test whether our constant ratio is correct. And how can we do that? We now use this formula. So we say we are at term 1. Our first term is number 10. Our constant ratio, we found 10. So AR means A multiplied by R. So we open a bracket here, we place 10. Then we are at position number 1. And remember, it means position of the term, which is 1. And, hey, I made a, oh, yes. I made the mistake. Did I make a mistake? Yes, I made a mistake. In the formula, I'm supposed to say Tn is equals to AR to the power n minus 1 here, minus 1. This is the formula. So here, I must come here and say minus 1. Now, we've got term 1, which is equal to 10, open bracket. When you say 1 minus 1, you get what? You get 0. So you've got 10 to the power 0. Anyone who has seen my videos on algebra, they would know that when you say 10 to the power 0, we get what? We get 1. So in other words, here we now have got 10 multiplied by 1, which is equals to 10. Then we can conclude that therefore, our first term is equals to number 10. And if you check here, our first term is number 10, right? Now, observe. We have got dash and dash here. We have been asked to find the fourth term and the fifth term. But in order for us to find the fourth and the fifth term, what do we need to do? We need to first find the nth term, And in this instance, when you want to find the nth term, your job is just to find the constant ratio, and of which we said our constant ratio is R. So the nth term would now be Tn is equals to A multiplied by 10. So A multiplied by 10 is equals to 10A, right? So we say 10 here to the power n. This is our formula. Tn is equals to A, open bracket, 10, close bracket to the power n. This is our formula. So what am I going to do? I'm now going to erase this so that we can find the fourth and the fifth term. All right. All right. What do we have? Tn is equals to A multiplied by 10 to the power n. So now we say term number 4 is equals to, our first term is 10, so we say 10, open bracket, it's minus 1 there. So we say 10 to the power, we're at position number 4, so we now say 4 minus 1. Please don't make the mistake of forgetting the negative 1. All right. Term 4 is equals to 10, open bracket, 10, close bracket, 4 minus 1 is equals to 3. So we've got 3 there. And 10 to the power 3 gives us what? It gives us 1,000, right? Let's just confirm with the calculator. So we now say 10 to the power 3, it's 1,000. Now, this 1,000, we must write that, okay, we have got 10 multiplied by 1,000. Now we must say this 1,000 multiplied by 10. I think it's 10,000. So we multiply by 10 and it gives us what? Voila. It actually gives us 10,000. So therefore, we can conclude that our fourth term is equal to 10,000. We have found the fourth term. We must now find the fifth term. We now say term number 5 is equals to 10 the first term, 10 the constant ratio, 5 minus 1. Term 5 is equals to 10, open bracket, 10 to the power what? 10 to the power 4. We now know that 10 to the power 4 gives us what? 10,000. And now, 10,000 multiplied by 10, maybe it must give us 100,000. Multiply by 10, what do we get? We get 100,000. So therefore, we can conclude that the fifth term is equals to 100,000. And when you want to verify what you'd have written, you just take this number and you divide it by the previous answer that you got. That's how you know whether you have written the right answer or not. So let's do it. Let's say term 5 divided by term 4, which is equals to the fifth term, it's 100,000, divided by the fourth, which is 10,000. These 3 zeros cancels those 3 zeros at the bottom. This 0 cancels this 0, and we're left with 10 over 1, which is equals to 10. So yes, the answers that we wrote, they are correct. That's how we know it, because we can always reverse and go back and find the constant, the constant ratio, right? All right. Now, on the next lesson, I'm going to be explaining the laws of exponents. Laws of exponents. Please do check out some of the videos which I've recorded about laws of exponents. I'm going to be recording from law number 1 to law number 4. Right? All right. If you found this video to be helpful, please consider subscribing. And if it was really helpful, please don't hesitate to like, share, and if there is any question that you'd like me to deal with, in the comment section, please comment, say, or make your suggestions. Thank you very much.